So, today we're going to look at graphing what we're going to call simple rational functions. Bless you. And then tomorrow we'll look at more complex rational functions too. Okay. Okay. So let me just quickly define for you. So a rational function is just a function in the form. So again, forgive me there. So a function in the form f of x equals p of x over q of x. Okay? P and q are both polynomials. Okay? So we've already talked about polynomials, right? We graphed polynomials. We focused a lot on multiplying polynomials, adding polynomials. Okay, we did a little bit with division too, right? And now we're going to be graphing polynomials divided by polynomials, right? Rational functions. And again, why rational? Well, remember, rational numbers are numbers that can be written in the form, an integer divided by an integer, right? Fractions, essentially. Okay, so that's a rational function. Okay, and of course, we have to stipulate here q of x is not equal to 0. Because if q of x were equal to 0, we would be dividing by what? If q of x were 0, we'd be dividing by 0, which we don't want to do, right? Because it goes to infinity. It doesn't exist. Okay? So we will be talking about this new parent function today, like I said, 1 over x, or I should say f of x equals 1 over x. Okay, f of x equals 1 over x. Okay. So again, I'll sketch out my little sketch here. Okay, for this function. Again, you can use a table of values here. You can use your graphing calculator and stuff like that. The easiest numbers to do are like x value of 1. So if I plug 1 in here, I have 1 divided by 1. And what is 1 divided by 1? 1. So I have the point 1, 1, for example. Those are easy reference points. Okay? But then also I can easily plug in negative 1 as well. So what's f of negative 1? Or in other words, what's 1 divided by negative 1 going to be? Negative 1. So I also have the point negative 1 as well. Okay? And these right here are going to be reference points for when we transform later. Because, of course, when we learn a new function, we have to transform it as well, right? And then there's our asymptote. I'm going to draw that in with a dotted line. Okay. I'm just going to abbreviate that as I won't abbreviate it this time since we are. Okay. Vertical asymptote. You don't really pronounce the P. You kind of do. It's kind of like an asymptote. You kind of like give it like a little break there, but you don't really go like asymptote or anything like that. Okay. So, and that's at x equals 0. And like I also said, we also have a horizontal asymptote too. I'll draw that with a dotted line right here. Okay. And then I'll go ahead and sketch in the curve itself. Okay. Oh, good morning. Interesting. And of course we have this other part too. Again, you want to be very careful here for these rational functions, at least for our parent function here, 1 over x, we do not cross the asymptote. So the asymptotes kind of create like borders for us, okay, that we approach, we never actually get to. Again, there are situations where you can cross a horizontal asymptote, but you will never cross a vertical asymptote. You will never cross a vertical asymptote. There are situations where you can cross a horizontal asymptote. So even though they're both called asymptotes, they have slight different characteristics, okay, when it comes to that. So, all right. Questions on any of this stuff so far? All right, good. So then, what would we describe the domain for this to be? Is it negative infinity to infinity? It's pretty close, isn't it? Is every x value okay here? No. What x value is not okay? 0. 1's okay. 1's okay. We can plug 1 in, right? We can do 1 divided by 1. But if I plug in 0 for x, 1 over 0 is going to be undefined. So I have to describe my domain, okay, in such a way that I exclude 0 and only 0. So there's 2 ways you can do that. Okay, if we want to use interval notation, then I'm okay to I can go to negative infinity, right? It goes all the way to the left there. So I can say negative infinity to, and then up to what? Where does this interval stop? Negative infinity up to 0, right? And then parenthesis, union, right? Put the little u in there to join these two things together. And then we'll also start at 0 and then go all the way to the right. So to what? Positive infinity. Very good. Yes, and I like that you said positive infinity there. Very good. Yes. Mm-hmm. Okay. So that's one way you can write it. Okay. Another way you can write it, you could just say all real numbers, because again we're talking about real numbers, right? No more imaginary stuff for right now. All real numbers except x equals 0. You can write something like that. If you want to write just a sentence, that's okay too, right? We're just describing the possible x values here. That's really what we're doing. Okay? Let's also describe the range. Okay? Is the range negative infinity to infinity? Is it all y values? Are we okay with all y values here? No, we're not. Which y values or y value are we not going to include? 0 again, right? We will not hit 0. You can see that visually there, right? So again, you can give me the same exact interval notation. Negative infinity to 0, and then 0 union 0 to infinity. Okay. Or you can also say the same thing, all. Now, if you want to get really fancy here, there's actually a mathematical symbol for real numbers. So if you don't want to write out the word real numbers, you can actually use this symbol here, and I'll show you. Okay, it's a capital R, but it's got two like vertical parts of the R, and then you just draw the capital R right through it, like that. Okay, so that's the same. That means real numbers. So you can say all real numbers except y equals 0. So if you want to be really fancy there, you can use that symbol. And I'll accept that too. Okay? So there's our domain, there's our range. Okay. Let's see here. What else do I want to talk about? Let's talk about end behavior. Okay. As x approaches infinity, f of x will approach what? Okay. So now as x approaches infinity, that means we're going really, really far to the left or really far to the right? To the right. Okay. What happens to our y values as we go, bless you, as we go further and further to the right? What do our y values approach? As we go further and further to the right here, what does it look like our y values are approaching? Yes, it's 0. Exactly right. It goes to 0. That's a strange end behavior, right? Normally we go to infinity or negative infinity, but this goes to 0. All right. As x approaches negative infinity, as we go further and further to the left on our function, what does our function approach? 0 as well. Yes, also strange behavior there. But yes, it goes to 0. Okay. Very good. Let me see here. What else did I want to say? Excuse me. Does this graph have any x-intercepts? Yeah, no, there are no x-intercepts, right? We're not crossing that x-axis ever. Does this graph have any y-intercepts? Does it cross the y-axis ever? No. No, it does not. Okay, so the parent function 1 over x, has no x-intercepts, no y-intercepts, because our asymptotes are along the x-axis and the y-axis there. So there's no x-intercepts or y-intercepts here. All right, what about let's talk about where is this function? Oh, is this function ever increasing? Is this function ever increasing? Are we ever going up from left to right? If we move from left, because remember, for increasing, you have to go up from left to right. Are we ever increasing as we go from left to right here? No, we are not. Are we ever decreasing? Going down from left to right? Yeah. So now, can I say we're decreasing for all numbers? Can I say from negative infinity to infinity we're decreasing? Or is there a place where we are not decreasing still? At 0. Yeah, we're not decreasing at 0. So we're going to say negative infinity to 0, union 0 to infinity. Okay? So because we see here, as we move from left to right, we are decreasing, right, going down. Then we kind of have to jump up to here, okay, and then we're still decreasing. So you might say, Mr. Wid, though, are we going up from here to here? Are we going up? Well, they're not connected, so no, we're not going up. We have to do this jump, okay? This thing right here, this little gap in our graph, it's called a discontinuity, right? It's discontinuous. Our graph has a break in it. All the graphs we've seen up to this point don't have breaks, right? They were all one smooth function, but this one has a break. Okay, it's a discontinuity is what we call it. All right, is it ever constant? Nope. Okay, it gets awfully close, right? It looks pretty flat here, but no, we're still decreasing the whole way through. All right, one more question here about analyzing the function. Okay, is it even, odd, or neither? Okay, Gio says neither. We're all in agreement with that? Even, odd, or neither? Bless you. Is it odd? Okay, how do we determine if it's odd? What are we looking for?
If it's flipped or
So yes, and rotate, not a flip. A flip, yeah, but I think I know what you're saying. But yeah, it's a rotation of 180 degrees, right? If I rotate this 180 degrees about the origin, it must be about the origin. If I rotate this 180 degrees, does it look like the same thing? It does, right? And so it is odd. It is odd. Okay, Gio, do you see why it's odd now? Okay. If it was even, right, we would have symmetry over the y-axis, but it's odd here, so we have an odd function too. Okay? Even if it reflects over the x-axis, or the y-axis, I mean. So if you can reflect it over the y-axis and it matches up. So fold it if you want to think of it that way, right? So like I have this upper piece right here. If I were to fold it, it would fold over to here where I don't have any graph. But you can see the rotation piece of it, right? If I rotate it, you can see it matches up. Okay. Questions on any of that so far? All right, let's talk about transformations then. Okay, so that's like your fundamental information there for parent, for parent function 1 over x. Let's talk about transformations. Now again, you guys seen this like a million times before. We're gonna do it one more time though because we need to. Okay. So. Let's see how this. So here are our transformations. All right, we have our parent function there, 1 over x, and there are our transformations. Okay, that we're going to worry about. The book puts in another transformation in front of the x here, 1 over b, but we can actually take care of that 1 over b with the a altogether, so I'm not going to have us worry about that. Okay, so, all right, let's talk about these, right? What is the k going to do? Up or down, right? Okay, and that does what you would expect, right? I'm not going to route the whole spiel here. I hope you will forgive me for that, or if you really want me to, I can. But if k is positive, right, if we add k, we're going to go up or down. If we're adding a positive k, we're going to go up or down. Up, right? And if we're adding a negative k, we're going to go down. Or if it's minus k, we'll go down, right? All right, very good. What's this minus h going to do? Left or right, exactly right. H units, right? Here, it's the opposite of what you'd expect. So if we see an x minus like 2, for example, that means we're going to go right 2, right? If we see an x plus 4, we're going to go left 4, okay? And then what is this a going to do? Reflect or, and also does a stretch, right? Vertical stretch or shrink. Vertical stretch or shrink. So yeah, if a is less than 0, reflect over x-axis. Okay, and then also stretch or shrink. You won't have to memorize it. I will give one to, like what's going to really happen is I would give one to you in this form, and you would just need to identify all the different transformations. Or, CJ, I'll give you a graph, and you'll have to come up with what the function would be. But again, it's just a matter of knowing the transformations. That's it. Okay? Sorry, stretch / shrink. Is that what you're having trouble with?
It says
a less than 0. Sorry, that's a less than 0.
No, the one below.
Also, stretch, shrink. Sorry. Also, stretch, shrink. Okay. All right, so let's just jump in then with some graphs. Let's jump in with some graphs here. Okay. So keep this handy, and we'll jump in with some graphs here. Is anyone still writing it down? Good? Okay, let's do some graphs then. And we're not going to take any baby steps here. We're going to jump right in with all 3 transformations, okay? Because again, it's like what we've been doing, really, right? I mean, it's just more transformations, more the same. Okay. Now, typically what we do, right, is we first transform, right? We first transform like our vertex or like the origin, right? And so if you look here, though, we don't really have like a vertex, right? But we do kind of have something at the origin. What happens at the origin? The asymptotes, right, crisscross at the origin, right? We have the vertical asymptote and the horizontal asymptote kind of crisscross. You can think like crosshairs, right? Like your target, okay? Okay? And so we're going to shift these crosshairs using our transformations, our shifting left or right, shifting up or down kind of situation. Okay? So let's just identify what kind of transformations we see here. This +2 on the end, what's that going to do? Up 2. Okay? What's this -1 going to do in here with the x? Right 1. And what's the 3 going to do? stretch by 3. Stretch by 3. No reflection though, right? Because it's a positive 3, so just stretch by 3. Okay, so far so good? Okay, so now, normally, right, again, our vertical asymptote and our horizontal asymptote crisscross at 0. So we're going to shift that, though, right 1 and up 2. So I'll draw my axes here. Okay, and we'll put in some numbers. So 1, 2, 3, 4, 5, 6. So, well, I'll wait for you guys to finish there. Remember, we normally have our vertical and horizontal asymptotes. They normally crisscross through the origin, right? But we're going to shift that point up 2. So I'm going to count up 2, 1, 2, and right 1, 1. Okay? Now I'm going to put just like a very slight dot there because it's not really a point on our graph. But I'm going to put this there because that's our new center point of our graph, right? These are where our crosshairs, right, the target is going to kind of align, all right? So again, normally our vertical asymptote and horizontal asymptote crisscross, intersect at 0, 0, right, the origin. But it's shifted up 2 and right 1, so I counted from the origin, up 2, right 1. There's my new center point, okay? So I'm going to draw the vertical asymptote. I'm going to use red here for this. So we'll draw the vertical asymptote right through that point. Okay? And then I'll also draw the horizontal asymptote through that point as well. So those are our new kind of like center or crosshairs or something like that you want to call it. Okay? For your targeting. Okay, so that's the first thing we should start with when we go to graph. Realigning those asymptotes, okay? They just shift the center of the asymptotes where they intersect just shifts, okay? So we're just going to shift those. The stretch doesn't affect them, okay? Now, let me go back one more thing. We have the asymptotes. We've got those down. We also need to get those reference points down too. And that's where we're going to account for the stretch. So the reference points will take into account the stretch here. So our normal reference points go up 1, right 1 from my center right there, up 1, right 1, and down 1, left 1. So up 1, right 1, down 1, left 1, right? Up 1, right 1, down 1, left 1. So here, since we are stretching by 3, I'm not going to go up 1, right 1. Instead, I should go up how much? Up 3. So from here, I'm going to go up 1, 2, 3, and then right 1, and there's a point on my graph. Okay? It's going to go up 3 from here. Okay, and then right 1. And likewise, instead of going down 1, left 1, I'm going to go down how much? 3. So 1, 2, 3, and then over 1, and there's another point. Okay? So these are my new reference points. Okay, my new reference points there. And now at this point, if you want to, you can try and get more points. You can, feel free to use your graphing calculator if you want to. You can type this in, let's see here. But we really do have kind of like enough information to get a good idea about what the sketch is going to be. But if you really wanted to, you can type it in. Just be careful how you type it in. 3 parentheses, 1, and then I need to use another set of parentheses for the denominator. Okay, so you see how I type that in there? You're going to do the 3. I'll put it up here so you can see that. So there's the 3, right? 3 in front of parentheses. And then 1 divided, and you must put that x minus 1 in parentheses. You will not get the right answer if you don't. And I put the plus 2 on the outside. Okay? I can go to my table, And if you want to, you can get some more points here. So, for example, we also have the point 4, 3, which is pretty easy to graph. So, 4, 3. Now, you'll notice 4, 3 is 1, 2, 3, up 1. Okay? So you see there's some symmetry here. We went right 1 and up 3. But you can also go up 1 and right 3. You get 2 points that will be on your graph that way. Okay? And I'll go ahead and just connect these dots. Remember that we're going to approach that asymptote and approach the horizontal asymptote as well. Okay? We can do the same thing down here. Again, we went left 1, down 3. I can also go down 1 and then left 3. 1, 2, 3. And there's a point right here. And again, connect the dots. Now, question. Yeah. Now, does this graph have a y-intercept?
Yes.
It does. Does this graph have an x-intercept?
Yes.
Yes, it does. Okay. Why now? Well, we shifted things, right? We shifted things around. Okay. So sometimes you can have intercepts and stuff like that. Okay. Let's just talk a few more things here. What would the domain of this graph be? What's the domain of this graph? What's the farthest left we're going to go? Negative infinity. Up to what? Where do we stop though for our x values? At what x value?
0.
Not 0 in this case. 1, yeah, to 1, right? Because we had to shift it right. You right? See right here, there's our vertical asymptote at 1. And then union 1 to infinity, right? What about our range here? Our range also has changed. We'll still go from negative infinity up to what though? Where does our range kind of have to stop or take a break? What are our y values have a break? We can see it there. What do our y values have a break? 2. And so union 2 to infinity. Okay. Show you one more here. And this one I might even, well, yeah, we'll see. I'll show you one more and then I'll talk about one more thing. We don't have to actually graph this whole thing if we don't want to here. We'll just go ahead and just talk about how I want you to manipulate it real quick. Okay. Now notice this next one is slightly different, right? Here we had the 3 and it was fully in front of the rational function here. Here we have this 2, but it's only in front of this bottom piece. Okay? But we can fix it. We can adjust this. We can manipulate this so that it looks more like what we need, which is right up here. Okay? And here's how we're going to do that. Okay? Since it's 2 times that, I'm going to kind of pull out a 1/2, okay? Because that 2, it's in the denominator. So it's not just 2 that I'm going to pull out. It's really a 1/2, right? It's 1/2 that I'm going to pull out there. And so this is equivalent to this right here, okay? Which I could easily just say then is 1/2 parentheses 1 over x plus 3 minus 1. Okay? When CJ comes back down. So now in this case, right? What kind of transformations do we see here? We're going to shift left 3, down 1, and then what's that 1/2 going to do? A shrink by a 1/2. Exactly right. So instead of counting up 1, right 1, we're going to go up a 1/2 and then right 1. Okay? So, and I can do that too if you want to. So again, we'll say left 3, down 1 shrink by 1/2. Okay. Do you guys want to see me do this, or do you get the idea of it? You guys get the idea from here? Anyone want to see me do it?
Yeah.
So you do it? Okay, I'll do it real quick here. All right, so let's see here. So go from the origin, we're going to go left 3 and down 1. So left 1, 2, 3, down 1. There's my new kind of center point on my graph. Okay, again, I'm doing a very slight dot there because, again, this point is not on our graph. We just use it to kind of center our asymptotes, right? So the asymptote will go through that point right there, and the asymptote will also go through it as well. Okay. So we have a vertical asymptote at x equals -3. We have a horizontal asymptote at y equals -1. Va and ha. Okay, and again, normally for our reference points, we would count up 1, right 1. But instead of going up 1, I'm going to go only up 1/2 and then right 1. Okay, so like right there. And you can also, if you want to, you can go right 1/2 and then up 1 like that, and there's a point right there too. Oops, I should have done those in red, I guess. Okay, so again, from that, where they crisscross, right, since we have that 1/2, we're going to count up 1/2 and then right 1, and that's a reference point. We can also go right 1/2 and then up 1, and that's a reference point too. And do the same thing here. Left 1/2 and down 1. And then down 1/2 and left 1. You can go something like that. And then just kind of connect the dots. Trying not to cross those asymptotes there. Questions on any of that? All right. One more thing here. One more thing. What if we want to graph something like this? Making it worse. Let me do it this way. What's different about this function that we want to graph than the other ones we've been graphing? What's different about it here? What's that? X on top, x in the numerator, that's right. We haven't graphed anything with x in the numerator. In fact, we've only talked about how to graph stuff when there's just a 1 in the numerator. Right? We don't know how to graph with x in the numerator. So we give up. No, we don't give up. Okay? Guess what we can do here? We're going to do long division. Oh, no. That's back, guys. Yes, it's back with a vengeance. So those of you that, kind of like just took the L on those questions earlier, you need to know how to do them now, okay, for sure. So I'm going to redo it here real quick.
Wow.
It's like that now. Okay, so we're taking 2x minus 4, we're dividing by x minus 1. Okay, look at your lead terms here, right? Okay, I need to figure out what times x will give me 3x. So it's 3. Yeah, it's 3, right? 3. So 3 times x gives me 3x. But also 3 times the minus 1 gives me minus 3. Right? So far, so good? Okay. We're going to, what do we do now? We subtract, right? And I'm going to distribute the minus sign. So I'm going to, instead of doing minus this quantity, I'll do plus the opposites. And so those cancel. And then negative 4 plus 3 is negative 1. So I have a remainder of negative 1. But of course, we're not going to leave it like that. I'll say this is equal to 3 plus negative 1 over x minus 1. Right? That negative 1, it's a remainder. We still have not, it remains to be divided still by that x minus 1. So it'll be, plus negative 1 over x minus 1. There's our function. Or if I put it in the more familiar, okay, what kind of transformations do you see? What's that plus 3 going to do? Up 3. What's that minus 1 going to do? Right 1. What's that negative going to do? Reflect it over the x-axis there. Okay, so now we can graph that, right? Okay, so that's the idea there. Questions on any of that? All right. And you guys can graph that from there, I think, right? And so we can also talk about how to write a function from its graph, right? So what kind of transformations do we see here in this graph? How is it transformed? Right how much? 3 up 4. Yep, so right 3, right? There's 2, there's 4, so that's 3. There's 2, 3, 4 right there, so that's 4 right there. So yeah, right 3 up 4. So that means we're going to have an x minus 3 and plus 4 at the end, right? Because we went right 3 and up 4. And then we have to figure out that a value, right? Now you can figure out your a value a couple different ways. You'll notice here in the graph, you're given some coordinates. So you could, once you have your your right 3 and your up 4, you can pick, an x and y coordinate here and plug it in to solve for a. Or you can also just count, right? We're going from here, we go up 2, right 1, right? Up 2, right 1, so that means 2 is going to be your a value there. Okay? So you can also do it that way too if you want to. Or again, like I said, you could use a point. I use the 0.46 there. So I put 4 in for the x, 6 in for the g. Or you could also use the 2 as well, your choice. Okay? And that's how you can write those functions. Okay? So again, very similar to stuff we've been doing already. All right? So I'm going to give you guys your assignment now, all right? And you guys have you practice on that. So it's going to include some graphing. It's going to include some dividing. You might have to be doing some long division, and then it's going to include some of this here too, where you're writing a function from the graph. Okay, and I'll come around and help you as we need to too. All right. So it's going to be in section 8-1. Okay, and I'll get you a page number here in just a second. Okay, numbers 1 through 4. Let's see here. Let's see here. I'll be do 9, 13. And 17. Yep, that'll be good, I think.
What's the page number?
I'll get the page number here in just a sec. Good. starting on page 287. 287. Okay.